Welcome to the Explainer. Have you ever stopped to wonder how a server in AWS actually gets its identity? You know, how it gets a stable IP address, or how you can swap a failing server for a healthy one in just seconds without anyone on the outside even noticing? Well, the secret to all of that is a core piece of AWS networking that we're going to dive deep into today, the Elastic Network Interface.
So let's just start with that really fundamental question. When you spin up a virtual server in the cloud, an EC2 instance, how does it actually plug into the network? How does it get an IP address, talk to your other services, or even know which security rules it's supposed to follow?
The answer to all of that lies in this incredibly powerful and, you'll see, surprisingly flexible component called the Elastic Network Interface, or ENI for short. The easiest way to think about it, it's literally a virtual network card for your cloud server. It is the one piece that defines how your instance connects to, well, everything else.
So here's our game plan for this explainer. We're going to start with the nuts and bolts of how ENIs actually work. Then we'll get into all the different network identities they can have, and that's when the real fun begins, because we'll explore some powerful real-world examples. Finally, we'll tie it all together and talk about why this is so critical for pretty much any modern cloud application.
Okay, let's get right into the mechanics. How does an ENI actually hook your server up to the virtual network? It turns out it's a pretty straightforward process.
It really happens in 3 simple steps. First, the ENI acts like an anchor, planting your instance firmly in a specific subnet. That's just a partition of your private network. Second, it gets its unique IP address from that subnet's available pool. And finally, and this is super important, it becomes the gatekeeper, applying all the security groups and route table rules to every single packet of data that flows in or out.
Now, this is where that word elastic in the name really starts to shine. See, unlike a physical network card that's bolted into a machine, you can detach an ENI from one server and reattach it to a completely different one, often while it's running. And this isn't just some neat party trick, it is the absolute key to building highly available systems that can fail over in a flash.
An ENI isn't just about a single identity, though. It's more like a chameleon. It can manage several different types of IP addresses all at once, and each one serves a very different purpose.
Every single ENI has what's called a primary private IP address. This is its core identity, its permanent address inside your private cloud network. It sticks with the ENI for its entire life, and it's what all your internal services use to talk to each other.
But you're not limited to just one. You can also assign secondary private IP addresses to the same ENI. This is an awesome feature if you're, say, hosting multiple websites or different microservices on a single server, and you want each one to have its own distinct internal IP.
Okay, so what about talking to the public internet? For that, AWS can assign a public IP address. AWS takes care of all the behind-the-scenes magic, mapping this public address to your primary private one. But here's the catch, and it's a big one. This address is dynamic. If you stop and restart that instance, you're probably going to get a whole new public IP, which makes it totally unsuitable for things that need to be stable, like a DNS record.
So for that permanent public-facing address, you need something different, and that's where the Elastic IP, or EIP, comes in. This is a static public address that you actually control. You can attach it to an ENI and it will stay there, rock solid, until you decide to move it somewhere else. This is the gold standard for any server that needs a fixed, reliable address that the whole world can see.
So let's just put it all together, because this is a crucial difference. A standard public IP, it's temporary, AWS manages it, and it's fine for just general internet access. An Elastic IP, that's a permanent asset that you control, and it's specifically designed for critical jobs like hosting your website or enabling that super fast failover we keep talking about.
And hey, this isn't just an IPv4 world. ENIs are totally future-proof because they have full support for IPv6. The key thing to know here is that IPv6 addresses are globally unique, so they don't need any of that translation mapping. When you assign an IPv6 address to an ENI, it is public and directly reachable on the internet right out of the box.
Okay, theory time is over. We've got our building blocks, this flexible attachment, all these IP types, security controls. Now let's put them together and see how these things solve actual real-world problems. This is where it gets really cool.
First up, let's tackle the big one, creating systems that can survive a failure. How do you make sure your application or your website stays online even if the server it's running on completely crashes?
This is what we call the failover maneuver, and it's beautiful in its simplicity. So picture this, your main server, instance A, just fails. It's gone. An automated script immediately detects this, detaches the entire ENI with its private IP, its elastic IP, and all its security rules, and instantly reattaches it to a waiting standby instance. To the rest of the world, nothing happened. The IP address never changed, your service is just back. All in a matter of seconds.
All right, here's another really powerful application. You can create multiple layers of security, not by adding more servers, but by using multiple ENIs on a single instance.
Check out this classic pattern. You can attach more than one ENI to a single EC2 instance. So here, ENI 1 is for your management traffic. It's got a super strict security group that only allows access from your internal admin network. Meanwhile, ENI 2 handles all the public application traffic open to the world on the web ports. It's a fantastic way to isolate different kinds of traffic on the very same machine.
And once you grasp these concepts, you can unlock even more advanced patterns. You can build what are called multi-homed servers that can act as routers or firewalls between different parts of your network, or, like we mentioned before, you can assign a unique private IP to every single application running on an instance, giving you this incredibly fine-grained control over your traffic.
So, we've covered a lot of ground. Let's just zoom out for a second. What's the big picture here? What's the one thing you should really take away from all this?
It really all boils down to this. The ENI is not just some simple connector. It is the fundamental unit of network identity for your servers in the cloud. It's the thing that gives you private IPs to talk internally, maps public IPs to talk to the world, enforces your security rules, and ultimately unlocks all of these flexible, powerful, and resilient network designs.
You know, mastering a component like the ENI is what takes you from someone who just uses the cloud to someone who can truly architect for it. It's a foundational step toward building genuinely powerful and resilient systems. So the real question is, now that you know how it works, what are you going to build? Thank you so much for watching. If you found this useful or if it sparked any new ideas for you, we would love to hear about it in the comments below. And of course, don't forget to subscribe for more deep dives into the technology that powers our